In the welcome note section, we had one person who was integral in making AWS user group happen. And now next we have someone who's very integral in making the user group community day happen. And Dijish was telling me that every time we announce the community day, we get a message from Mohan Thomas saying, cheers, I'm in. And HiFX is a platinum sponsor this time. We are grateful to have Mohan Thomas amongst us. He's going to be talking about bridging continents in the cloud, a seamless migration from Ireland to Bombay. Someone who truly believes in unit economics and who has been associated with AWS for the last 14 years. Can we have the loudest round of applause for Mohan Thomas on the stage, please?
Hey, I'm super excited to be here, to be part of this event. Being associated with this event since, I think it's 2019 we got started. So being part of this event for the last almost all the 3 years and then support in whatever way we can. My name is Mohan and I am a director and the CEO of HiFX right now. And we've been associated with AWS since 2010. So we had the first project on AWS in 2012. And at the point of time, we never had an AWS office here in India. So the entire thing was actually handled by the team from Singapore. And then based on that success of that particular project, we were given another project to migrate from the data center in the US to the cloud. The first project that we did was kind of right from the ground up, so we never had any kind of issues or challenges. But the second one was a project that was with the client since 2008. And we had, at that point of time, almost 4 years of data, different challenges and things like that. So let me just quickly take you through our experience, and I want to share some of the few ways in which you can optimize the cost, you can improve the cloud performance, and giving it back to your customer. Okay, so let me just give an introduction, just a brief introduction to the project that we have had. So in the year 2012, we were given the task to lift and shift what we call from a data center in the US to AWS. So we had to actually design the application for the cloud. And in 2014, as you know, AWS is still growing. So the number of services they had, the number of managed services they had was pretty much little. So I think around 60 to 70, and then now it has grown up, right? So then we had the challenge of moving from the Oracle to RDS. So we used MySQL at that point of time. RDS, MySQL, Aurora came in later. Oh, on the center. Okay, thanks. Okay, so yeah, and then we had various challenges especially when we moved from an application that was done in 2008. There was no code versioning and things like that. So we went live in 2014. And from 2014 to 2023, we were actually improving the application, I could say. So if you look at it, we had the automated resource provisioning coming in that point of time. Then we kept modernizing the application. So we moved from RDS, MySQL to Aurora to especially take the most benefits of Aurora at that point of time. Then we moved to Docker, we moved to Kubernetes. Then we migrated from Solar Cloud to Elasticsearch. And then we moved from normal managed, our own Redis implementation to the managed services. So we're trying to use the maximum AWS services so that we can actually bring down we can actually improve the efficiency, and then they take care of the things. And one of the challenges that we faced in 2014 was when we went with our own implementation of the Redis cluster, right? So the way in which the failover was functioning was we had so much of trouble. And especially we just could fix it I think around 10 to maybe an hour before we actually went live. So from that, if you look at it, AWS is giving us tremendous opportunity, tremendous release in terms, I can say, trying to use the managed services. So that's where we are. In 2023, we were given the task to move this particular application from Ireland to Mumbai. You may ask why, because especially because of the new data privacy policy that is coming in India. So we have to ensure that all the customers' data that is there in Ireland will have to be shifted back to Mumbai. So we used that opportunity to have a look at the whole application, fine-tune where we could fine-tune it, improve where we could improve it, and then pass on the cost benefits to the customer. So if you look at it, we use a couple of, these are the services, the AWS managed services that we use in the application from Aurora, OpenSearch, we have the ECS, Redis, clusters, Cognito, Lambda, CloudWatch, whatsoever. And then we have our own managed services. What we do is RabbitMQ, Grafana, ElastAlert, our own analytical dashboards. Then we use Rundeck. And then there are a couple of third-party services also, like Akamai, mainly from Akamai, the DNS, the web application firewall, CDN, and also we use Datadog for the infrastructure management and things like that. You may ask why Akamai and not CloudFront. So we are actually working with AWS team, the CloudFront team, one way or the other, trying to improve the services. But I believe in 1 or 2 years, definitely we'll be able to remove Akamai and put in CloudFront. So, yeah. So this was the kind of approach that we took. So we sat down, we came up with an approach, we charted down the challenges, and who is going to be responsible for all this, each task. And then we have to consider about the data security, because we are moving away from Ireland to Mumbai. We have to consider in what ways that we can actually do it, and then monitoring and optimizing the whole thing. So we took it up, the DevOps team, then we had the support from the application development team and also the QA team. And the client team, they said they will manage the DNS, the switchover and everything. Okay, so what are the challenges that we expect? I think you'll also face this very similar kind of challenges when you are trying to move from one data center to another, or maybe from one cloud provider to another. The one was like how to block the incoming traffic gracefully. And then we have to consider about the data size, right? So we had over 10 terabytes of data in S3 with 13 different buckets in production. Then we had close to around 550 GB in RDS with 1 writer instance and 2 reader instances. Then we are using OpenSearch. So we had close to around 15 gigabytes, and Redis, it's the cache, we're talking about 40 gigabytes. Then the other question is like how we minimize the downtime and cost. So we are talking about an application that is already running from 2008, right? So there are a lot of customers using it. There are a lot of people, profiles being created. There's a lot of, money. It is a money-making application, so we have to ensure that we minimize the downtime, and also, as I said earlier, come up with some things, analyze the existing infrastructure to see we can improve, bring down the cost, and then pass it on to the customer. So we did that. We calculated the time it takes to complete each task by simulating it multiple times. Prepared a detailed timeline based on the tasks and shared the responsibilities, and right-sizing the AWS resources to minimize cost. So this was the approach. The first one, the existing application was not using Terraform, so we wanted to ensure that we moved to the new paradigm out there, the infrastructure as a code. So we thought, okay, we're going to rewrite the whole thing, the infrastructure enablement. We use Terraform, and use updated and improved Helm to deploy the application in the Kubernetes cluster. We found that we are not using Helm to the reach full potential. We are not using the global variables as such. So we thought we'll improve that. And then use auto-scaling group configured to create the Kubernetes worker nodes, the RabbitMQ cluster, the queue consuming application that process the data from the RabbitMQ cluster. Then use the backup the cross-region Aurora cluster, and also ensure that the Rundeck servers are also set up. And then the other thing we're talking about is Kubernetes add-on to handle unexpected node terminations, Lambda functions to automatically create the CloudWatch alarms, and S3 buckets and lifecycle policies. So this was the kind of approach that we took. And then the rest was like, okay, for us, the single source of truth is still Amazon Aurora. Then we wanted to actually populate the data in Elasticsearch and Redis using custom scripts. So we brought in the development team, we asked them to write the scripts more efficiently to populate the Elastic Redis and the OpenSearch. And while populating, we ensure that there is no throttling in resources. The data is completely in sync with the master database, and created a separate stack for each operations in the future, because we don't know what's going to happen. So we have to ensure that since we have the source of truth, the script is always ready. Anything goes right, we can actually spin off the instances in another data center or another location, and then we can actually get the application going. And then finally, test the application stack, do the load testing, and then finally go live. So just digging a bit more deeper into the Terraform functions. So the whole approach was like we'd go with a variable file-based resource provisioning strategy. And then because we have a production environment, so most of you all will be aware of it. Right? So we'll be having a production environment there. We'll be having a staging, and also we'll be having a DR, right? So we have to ensure that a proper variable-based structure so that we will reuse as much as we can, and then it's more efficient. Then divided the responsibility of each module to a 5-member DevOps team. So each team member was developed the resources assigned to them. It was peer reviewed and pushed to the master branch. So what did we do internally? So see, leverage the power of the built-in Terraform functions and resource blocks to develop reuse modules. If you look at the bottom right, sorry, we have the variables for the production DR and variables for the production, 2 JSON files you can see. So that is where we are actually keeping the variables for the DR region as well as the production region. And we use a single code base to create multiple environments, you see. And then use minimal code using Terraform meta arguments, like for each, count, and depends on. So this was the kind of approach that we took. It worked superbly for us. Maybe for you, some of you, maybe a tweak here and there would be required. But most of the cases should be go like this. And I talked to you about the weakness that we had with the existing Helm implementation. So we wanted to go with the umbrella chart structure and the use of global variables so that the parent-child relationship can be met. And we use templates from Helm and deployed the Kubernetes add-ons via Helm with the cluster autoscaler, node termination handler, load balancer controller. So if you're actually working on a large Kubernetes cluster, all these things you're probably aware of, right? You have to ensure that the node can get terminated, the load should be balanced between the pods, the cluster autoscaler, all these things is quite handy for you guys. And we also decided that we'll create the whole logging monitoring stuff for the Kubernetes cluster and for the infra using Datadog. We have an ElastAlert. We use Prometheus and Grafana. We have a metric server that collects the metrics, analyze it, and Fluentd also. And then we have the headless services as well, especially for the RDS and the OpenSearch. So once we have the application stack ready, right? So what is the next step that we probably will have to do? It's mainly, it's like, okay, we have the production environment. Now set up the production environment using Terraform scripts. Do it multiple times to see if things are actually working for you. If it works, okay, now identify the data to populate the production environment, right? And then test the scripts developed by the development team. So that's a script that is we are going to use to populate the Elasticsearch, the OpenSearch and the Redis cache. And then do load test and monitor the metrics. This is pretty important that you do multiple load tests because you're actually moving away from one environment to another to ensure that you don't have any last-minute glitches. And identify the bottlenecks, fine-tune the infrastructure, identify the right resource family. So that is super important. Identifying the right resource family, because we have quite a lot of instance type that is coming out daily, or maybe I think in a quarter the new resource types are coming in. Some are compute oriented, some are memory oriented, and some are network oriented, right? So if you're using a Python application, mostly it will be compute, the CPU intensive. So you have to ensure that that's taken care of. If you're using Elasticsearch, your own custom implementation, it could be a balance between the memory and the the output plus the compute. So all these things you have to consider the right kind of resource family. So that is also pretty important. So how did we go about this? So we had the QA team come up with a plan. So they created 2 testing suites. One was for the API. We used Cucumber and Gatling. And the other one was the test data user creation suite for using the robot framework. So we have to create quite a I think it's got, yeah. So we have to create quite a lot of these.
Okay, so we had to. So we have to actually use the robot framework to create quite a lot of this user data. And the important things that we find was to monitor the metrics and identify the bottlenecks. This was not a one stretch go. We had to do it multiple times. We had failures. We had the instance going down. We had instances throttling unnecessarily. So we had to come up with the right kind of mix for the whole thing. So that was done multiple times to find out the right kind of instance that we need to use and provision the production capacity to match the testing data. Now, once the whole environment was set up, we had to get the client approve our data security plan. So this is how we did it. Yes. So move data through secure AWS network itself. We are not using any kind of third party. We are not using any kind of Dropbox or any third party S3 services or anything like that, just within the whole environment of the client itself. So we used AWS local network wherever possible, VPC, peering, RDS region replication. We leverage the power of Kubernetes cluster objects like PVC, POD, shared volumes, and job controllers to speed up S3 data transfer. We use encryption and code scanning to ensure that, okay, there is no rogue thing that is coming. The next thing was on the IAM permissions, right? So we have to ensure that the restricted access is via security groups, configured the IAM permissions that are really needed. Just restrict the usage of the asterisk. So don't give just blind access to ensure that everything is in order. And before we started the migration, what we did was we created the Aurora cross-region replica in the destination AWS region that is in Mumbai. And then we declared a code free saying, okay, this is the final, and this is how we're going to, this is the cutoff time and date. And then we configured the lifecycle policies to replicate the S3 buckets. Use Terraform scripts to provision Elastic Cache, Redis, and the Amazon OpenSearch. Then we created the EKS cluster for that and other related services using the Terraform scripts and use Helm to deploy the application, the EKS cluster. So that's how the whole thing was planned. And then at the time of migration again, see, we had to actually block the network, incoming network using network ACL. So this was something that we could also try out. It worked well for us. I think it's the recommended approach. And then populate the data in Redis and OpenSearch by executing the custom scripts written in Golang, because that was the kind of the high performance thing. We had to read around 550 gigabytes of data, populate the Redis, populate the Elasticsearch cluster. So that was a time that is going to take so much of time, right? So data population stack in 3 separate auto-scaling group of RabbitMQ clusters and consumer servers and EC2 instance. And we are actually keeping this along with us in case if tomorrow if a need arises, we can actually use that again. And then we tested the whole application using the spoof IP and switched the DNS to take the application live. Now what about monitoring and optimization? These are the things that we use internally for all the applications that we do. We use CloudWatch. We monitor almost all the AWS resources to evaluate the performance on a regular basis. We create dashboards for the stack for overall monitoring. So everything is measured as I said, my focus is mainly on unit economics to the client. So we give importance to all these, the cost, and are we using the right kind of instances? Are we going wrong anywhere? Is any kind of throttling happening once in a while? And all these things are really taken care of. And then Elasticsearch, we have a custom implementation within the application to monitor the application logs. We look for 500 series errors. We take it seriously. There is anything that is going wrong. And then we found that there are some static assets being served from the application containers. Discussed with the developers and implemented caching for some of the same. We use Grafana to detect any kind of Datadog, which are always aware of, most of you are aware of. Continuous monitoring, helped in setting requests and limits for the pods, created customized dashboards. So all these things we could do because we ran multiple load tests and stress tests. And we measured the latency in every case. We want to ensure that there's no lag in terms of the response time from any of the services. So all these things were taken care of. And these are the few kernel optimizations that we did inside the EC2. Sometimes these are things which we normally overlook, but we do it regularly, or we do it before any kind of applications that go live on AWS, just to ensure that we are getting the maximum juice out of each and every AWS instance. So the memory swappiness, right? So we made it to 0 to limit disk reading, so that the applications, the containers that runs much more faster. We increased the huge page usage to help with memory management, because that helps the other one. Enable file system page caching behavior, we increase the size. So if you have worked on kernel level, you'll be familiar with all the parameters that need to change, but these are things that you can probably refer to. Enable the option to reuse closed sockets faster. We increased the large connection range available, increased to 2.6 million. Increased the maximum number of backlogged sockets, allotted 16 MB per socket. There's one more thing. The important thing is that the connection tracking to prevent drop connections, right? So we increased that, we improved that, so that this will handle the load balancer issues. So if you're actually working with quite a lot of load balancers, this is one of the things that you need to look at, the NF Connect Track Max. Then, as usual, always, if you're working on a Linux, you know that you need to always increase the open file size limits. So we did an audit also, the same thing, right? So I want to share those things that we found, so that it will be useful for in your projects also. So a lot of things like on horizontal scaling versus vertical scaling. So we know what our application should be always horizontally scalable, but there are certain cases wherein we also need to consider that sometimes vertical scaling is also good. And we tuned the Kubernetes pods. And see, look at it. This provision the network hungry pods to C5N instances. So that's where the entire Envoy thing is working for us, because that is so network intensive. So we moved those things to a C5N instance, right? So this was one of the, if you're working with OpenSearch, right, there are a couple of parameters that you need to look at. So one is the thread pool queues. That is basically how much time your request is actually waiting to get a response. Then there are JVM memory pressure also. So we tried using C5X large, R5X large, and M5. So you can see how the thread pool is, the behavior of the thread pool, right? So in C5X large, it was fine, but then we had minor spikes. R5X large is not suitable for this search function that we have. And look at the memory also. Like, see, the memory, the M5X large it's kind of more stable kind of a rhythm, right? So we went ahead with that M5X large. And look at the CPU utilization also. So if you go with the M5X large, look at the CPU. It's kind of a proper rhythmic wave. And the cost also is good. In terms of M5X large, we're just spending around $10,000 a year. But if you look at it, there is $13,000 and another $500 more. And then what we plan to do now is we're trying to bring down the number of instances, a number of nodes, so that we can actually pass on that cost saving to the client. And one of the other things that we found was one of the things the developers missed, so they're not using the writer endpoint and the reader endpoint properly. So we had to actually take care of that also. But there are certain cases wherein we cannot use the reader endpoint every time, because there are certain times when we do an immediate update or insert and we have to take the count sometimes. Because of the replication lag, you might get an old data, old value, right? So this was a time that we found out, okay, we could improve on the throughput and the CPU utilization. You can see that the writer endpoint is low, but then we have to actually revert it back. We're working on a code change to make it work. And what we plan to do is to use the write forwarding feature for that. So this is how the last thing works out for us. After the migration, the cache is like 40 gigabytes. We have 550 GB in Aurora. The search logs is like 733 gigabytes. And then these are the various S3 buckets out there. Before I conclude, I just want to pass on some important things that you could use for your S3 buckets. If you're using S3, it's pretty important that you understand the different storage classes that you can use to help you with it. Especially deal with versioned objects, expired object delete markers, and incomplete multi-part upload objects. So if you keep it open, you'll finally end up paying more for the S3 buckets. So this is one of the projects that we did. We had a project that came up, and look at that. We had one S3 bucket with 170 terabytes of data with a lot of versioning happening internally. So we cleaned up all that, and the number of objects dropped from 450 million to less than 150 million. So the client was actually paying for nearly 300 million objects unnecessarily. And the storage size dropped from 170 terabytes to 140 terabytes. So we're still working on improving it. Right? And then we use Glacier too. You have to ensure that you just don't use Glacier just for the sake of using it, but ensure that you use Glacier only for large objects and not for small objects, because a lot of the cases wherein if you use small objects, AWS internally maintains metadata files with like 32 KB and 80 KB of data that keeps growing. So if you just look at this orange and the blue one and the red one, you can see a small green one there. That is the AWS internal data, which we also have to pay for. So you have to use all these things, resources wisely, because customers committed to you the AWS account, and it's up to you to give them the best possible solution, a cost-effective solution, so we can actually pass on the benefit to the client. Okay, so that's it from my side. I hope this was informative to help you with the migration process. Thank you so much.